All right, you guys. Hello, everyone. It's Miss H coming to you live from, you guessed it, the kitchen table. Today we're going to do 20.2, hard to see right there. We're going to do something called arc length. You guys are going to like this lesson. It's just a quick little formula. We plug things into it. We do use our calculators quite a bit to either get some decimal answers or some fraction answers. So make sure you've got your calculator handy, or you're using the calculator app, Texas Instrument, through the computer, or you can use Desmos. Either way, we're going to just want that today. We're going to go through a couple quick definitions. We're going to give you the formula, and we're going to do 4 examples, and then I'll give you just some quick homework help. Okay, so let's get started. Before we do anything, I just want to go ahead and recall 2 different things. We're going to recall that you guys learned about central angles. So a central angle is when we had a circle. Oh, shake the camera. And we have an angle here that's starting in the center of the circle. So if we have that, we know that whatever degree this angle is, this arc degree is also the same. Now, this arc degree is different than an arc length. I'll get to that in 1 second. I also want to recall that we have a circumference. The circumference of a circle measures the distance all the way around. And for that, our formula is circumference equals 2 pi r. Our formula today is just going to build on that. So if that looks familiar, that's great. If it doesn't, no big deal. We're just going to have our formula build on that. What is arc length? It's just a piece of a circumference. So again, a circumference measures the distance, not the degrees, the distance all the way around something. So an arc length is just going to be a little piece of that circle. Okay, and here's our formula. Arc length formula is, and I might say AL just for arc length, it's going to equal 2 pi r, just coming from this guy up here. And then we're going to multiply it times this central angle. Hence we learned or recalled that guy. Central angle divided by 360. So we can kind of see that we're going to need our calculator to multiply these guys together, do some fraction work. Like I said, some answers are going to be decimals, some are going to be fractions. Some you're going to leave pi the way it is, and you'll work with all the numbers around it, and then slap pi onto your final answer. With other ones, we're going to let pi equal 3.14, and it'll be just a decimal answer. So it just depends on the problem. Okay, so let's see this at work here. Here's example 1. And the directions are just going to be to find the arc length. So we've got to give ourselves a circle and a central angle somewhere in there. I'm just going to label everything A, B, and C. So we need a couple of things. We need a radius on this guy. We're going to say that it's 5 feet. We are going to have units on all these answers, so I just encourage you guys to keep track of your units. We also need to know this central angle. So I'm going to say that this is 30 degrees. And that's all we need to know. We are good to go. We're just going to plug everything into our calculator. Now, the directions here did not say to let pi equal 3.14. That means I'm just going to let pi be pi. So our arc length is going to equal, I'm just going to rewrite the formula, 2 pi r. I'm going to put CA for central angle over 360. And I'm just going to plug everything in. So this 2 comes down, this pi comes down. What's our radius for this guy? 5. I'm not going to put the units in there. 5 is good. Times, what's our central angle? Let's bring down that guy. Central angle over here was this 30 degrees. 30. We're going to divide it by 360. And there we go. We plugged everything in. We're going to let our calculator figure out some of these calculations in here. And we're going to leave pi just like it is. So I'm going to work this way. I'm going to, on the calculator, put this guy, and this guy straight into the calculator. And I'm going to keep it as a fraction answer. So 2 times, and I had parentheses, 5 times this guy. This is 30 over 360. So I'm going to do 30. And then to do over, just a division. 360, that's it. Hit enter. What a beautiful decimal. We don't want decimals on this one. On the homework, you will not be finding decimals. So everybody in my class knows this really well. Hopefully everybody does. What are we going to do? We're going to hit math, enter, enter, and it turns that guy into a nice fraction for us. The online version of the calculator will do this. Somewhere in Desmos, I believe it does this, but you can find a converter online. You can just Google converting decimals to fractions, and something will help you out. So there we go. So I'm going to have 5/6 here. I don't want to forget this pi, so I'm going to put pi here. And then this is a distance. So what units are we using here? Feet. There we go. So that is a very typical arc length formula problem. Everything's going to look and feel just like this. On the homework, do you need to write down the formula each time and show me what you're plugging in? No, but I just wanted to show you that that's how we got this answer. Pretty good? Okay, let's see another example. Example 2. Again, we're just going to find the arc length. Let's go ahead and say let pi equal 3.14. So this means I'm going to get a decimal answer. I'm not going to get this guy. I won't have pi left in my answer. I'm going to turn this into 3.14, multiply these all together. It's easier to do on the calculator. Let's go ahead and draw ourselves a picture like before. Another circle, a central angle, ABC. This guy looks really nice. He's got a 90 right there. So I know that that's 90 degrees. And then for this radius length right here, they're telling me that it's 3 meters. So I'm good to go. I'm going to just write my formula just until I feel super comfortable with what I'm doing. I'm going to plug things into it. Looking for this arc length, I don't know. 2, what am I plugging in for pi? 3.14. What am I plugging in for my radius? Just 3. And then my central angle. This guy doesn't tell me, but we know what it is, 90. Again, over 360. This guy is absolutely calculator ready. We can just plug this whole thing in and get an answer. Here we go. Can we see that? Yeah. So 2, 3.14 times 3 times, and again, to put this fraction in, 90 over 360, we just use this division button right there. If I hit that, there it is. There we go. And there's our answer. It'll probably tell you to round to 2 decimal spots, and look at that. It's a perfect 2 decimal spots. So here we go, 4.71. And again, I don't want to forget the units. We are talking about a length, a distance, how long something is, always is going to deserve some sort of units. So we've got meters. There we go. So a quick example on how to keep a fraction, and a quick example on how to do a decimal. Once again, how do you know what it wants? If it wants a decimal, it will have this. Let pi equal 3.14. Okay, we have 2 more examples. Example 3 is how we're going to sometimes work backwards on these problems. Meaning, they're going to give us the arc length, and we're going to work backwards to figure out some other missing piece of information in here. So on example 3, we're going to work backwards, and we are going to find the radius and the diameter. So I'll make a little key for us right here. R is radius, D equals diameter. And let's just go ahead and talk about it real quick. If we know the radius, we just double it to get the diameter. If the radius is 5, we double it to get 10 to get a diameter. Okay, let's draw a little picture. We need a central angle. This guy's facing down, A, B, C. This is 120 degrees. And they're giving me this arc length here as 8 pi. So we know that 8 pi is our arc length. And again, I don't see up here to use 3.14 anywhere, so I'm going to leave everything in terms of pi. So let's put our formula down. Arc length equals 2 pi r central angle over 360. And again, let's just plug in what we know. We're going to try to find radius. We're going to come back and find diameter in a second, but we can find radius first and, like I said, get a quick answer for diameter. Let's plug in this. Arc length is, there it is, 8 pi equals, we got 2, we've got our pi. What's our radius? We don't know. That's what we're looking for. And then what's our central angle? This guy over here, 120 over 360. Here we go. So we've got to go ahead and solve for r here. This is, again, working backwards where we can't just plug things into the calculator and get a quick answer like we did here. We're going to have to take our time and kind of pick away at it. The first thing I want you guys to do is just cross out those pi's. And then we can even rewrite this so it looks a little more simple. It's just 8 equals 2r 120 over 360. So there's a couple of ways that we can get an answer here. Depends on how we like to do it. We can immediately get rid of this 2 by dividing both sides by 2, or we can kind of combine like terms with these guys first. I recommend we do that. That's just what we do mostly in class. So 8 equals, I want you to ignore this r, and I'm going to do 2 times 120 over 360. So 2 120 over 360. There we go. And like we said, no decimals on this guy. Math, enter, enter. Let's get that fraction. There it is, 2/3. So those numbers combine to make 2/3 r. Okay. Now it's looking a lot easier to solve for this r. I want to get rid of this 3 first. I'm going to multiply by 3. 3 times 8 is 24 equals 2r. 1 move away to solve for r, divide by 2. And there it is. R equals 12. And then we just double a radius to get to a diameter. So diameter equals 24. What was the units we were using on this? Were there units anywhere in here? There really weren't. So I'll just leave out units. Maybe I'll remind myself that there should have been units in here somewhere by just writing U for units. But that's our answer. I know it feels like it takes a lot longer than the above problem, but we are falling back on some algebra skills and at least some calculator skills to help us out here. So that is a working backwards problem. I think there's one of those on the homework. You can do it. If you need help with these calculator commands, with making sure that your calculator is working properly, that you've got the right app or the right program, just ask your teacher right away or ask somebody from Cougar Excel if you guys are using the CAVE tutors. Anybody can help you with that. Okay. Oh, and this is our last problem. It's a word problem. Like any word problem, we're going to read it, we're going to draw a picture, and we're just going to use the same easy formula that we've been using. So we have Stephanie jogged around a circular track. I know a lot of tracks are oval. We've got a circular track. She found the angle to be 270, giving us that central angle we need. The diameter of the track is 120. Well, we don't want diameter, we want radius. Okay. What is the length of the arc length that she jogged? Ooh, and right here, let pi equal 3.14. I know I'm going to use decimals. Okay, so let's draw a picture. Here's Stephanie. Look at that. Oh my gosh, she looks amazing. She's starting here, and she's running along the track 270 degrees. That's actually 3/4 of the way around. So she's running from here to here, giving us this central angle of 270. Got it? We need to know this radius, which we don't know right now. What do we know that the diameter is? Diameter is 120. Therefore, what would this radius be? Be a half of that, 60. So I'm going to label this guy too. I think we are in feet. Yep. Okay. There we go. There's our picture. We've got our central angle. We've got our radius. We know we're going to plug in pi equals 3.14. Let's do it. Arc length equals 2 times pi 3.14 times our radius, 60, times our central angle, 270 over 360. This guy is calculator ready. Just plug it in just like you see it, and we'll round off our answer to 1 or 2 decimal spots, whatever makes the most sense right now. And we'll put our feet units on it. Okay, so 2 times 3.14 times 60 times 270 over 360. Quick answer, there it is, 282.6 feet. All right, there's a word problem like this in the homework. I really recommend you draw a picture, try to keep track of what you know, plug everything into your formula, and get your quick answer. All right, you guys, good luck with that homework. Again, thanks for sticking with me on this. I know I talk a lot, but I'm always trying to convince you guys that you can do this. You guys have got great math skills. I know we're working from home, from our kitchen tables, and we're sharing our computers and our technology with everybody, and it's stressful, but I really, really believe in you guys. And if you need help, reach out. Okay, guys, bye-bye.